Okay, so this is the second video we're making. This is about converting from number of moles to formula units and from formula units back to the number of moles. Um, Here, as you can see, I don't have the mass of silicon or aluminum written out. That's because we don't actually need the mass. We're not going to calculate the molar mass for this one. The only time that we need to calculate the molar mass is when we're going from formula units to number of atoms. And this will be something we'll have to talk about later in a different video. But this is actually pretty easy. The only thing that I need to know is this Avogadro's number. Avogadro being a philosopher and mathematician, and he came up with this idea of grouping things into this big number, which we write as n sub a for Avogadro, and it is that 6.02 times 10 to the 23rd. And it means that there are 6.02 times 10 to the 23rd of something inside a mole. If I have 6.02 times 10 to the 23rd hydrogen atoms, I will have a mole of hydrogen atoms. If I have that many carbon atoms, I will have a mole of carbon atoms. And because carbon and hydrogen are different sizes and they have a different number of protons and neutrons and stuff, they weigh different stuff. They're different numbers, right? So my mole of hydrogen is going to be significantly lighter than my mole of something like, say, lead, which is a really heavy element. But we need this number because it allows us to convert between a number of individual molecules and moles. So if there are this many formula units, or FUs, as we'd said, per 1 mole. A formula unit, that can be a molecule, it can be an atom. It really depends on what the question is asking. So here we're asking about silicon, and this is an element. And so when we say we have 1.76 moles of silicon, it means that we have that many moles of just this element. So there's no molecule, there's no like carbon and oxygen, it's just silicon. It's a pure substance, and there's nothing else but silicon in it. So, to do these problems, the first thing we need to do is look at what we have. We have 1.76 moles. And what we want are these formula units, or in this case, they'll be atoms, because silicon, like I said, is a pure substance, or just elements. So at first, I will write out my 1.76 moles. And then I do my little boat thing, right? So here's my above deck and my below deck. Remember, we're on Mole Island right now because we have 1.76 moles. And what we want to do is take our moles and store it down below deck, so our stuff for Mole Island, all of our gear that we had from Mole Island, all of our shirts and equipment and whatever else we were doing while we were on vacation in Mole Island, that goes below deck because what we need up on top deck is what we're going to use on our FU Island. That's where we're going. So up top, we have 6.02 times 10 to the 23rd. And this would be FUs. Here, I have moles on top of a division. This is basically moles divided by 1. And here I have moles down below. And these cancel because we are dividing something by itself, and that just cancels out. So if I plug this into my calculator as 1.76 times 6.02 times 10 to the 23rd, I would get my answer for the number of moles. And when I put that in the calculator, the answer I get is 1.06 times 10 to the 24th FUs. But again, this is silicon, and so these are atoms of silicon, and I can write either FUs or atoms. Either one would be correct. If you wrote molecules, that would be an issue because silicon is not a molecule, it is an atom. But FUs or atoms, either one will be acceptable. Okay, so down below, I have another problem. Is how many atoms are in 4.1 moles of aluminum? Just like before, aluminum is just an element, so this is going to be the number of atoms that we're going to get. Aluminum is not a compound, it is just Al, the element. So we don't need to worry about, do we need to go to FU Island and then to Atoms Island? No, we just need to do this one conversion. And our FUs or atoms will be our result. So here I have 4.1 moles, and I'll write that out, 4.1 moles. And then I do my boat thing. So here's my boat. And below deck, because we are on Mole Island right now, on it, we want to get all of our mole stuff down below in the storage area. And then we want to bring all of our stuff from FU Island up to the top so it's ready to go with us when we get to FU Island. When we take our boat across, that's going to be the 6.02 times 10 to the 23rd that will get us there. So if I take this, I do 4.1 moles times 6.02 times 10 to the 23 FU divided by 1 mole. And again, my moles will cancel just like they had in this video, in the previous one as well. And moles cancel, and I am left with just my units of FUs, and that's ideally what we want. So when I plug this into my calculator, I would type in 4.1 times, and then open parentheses, 6.02 times 10 to the 23rd, and then I would close my parentheses. So your calculator should look like this, 4.1, open parentheses, 6.02, and then you could do the E23, or you could do 4.1, open parentheses, 6.02 times 10 to the 23rd. These are the same thing. However, in your calculator, do not do something like 6.02 times E to the 23rd. This will give you 10 to the 24th, and that will mess up your answer. So your answer will be correct for the most part, except when you should have got like a 10 to the 23, you'll get like a 10 to the 24th instead. So make sure that it's either E or times 10 to the power of 23, but not times E 23. Okay, we'll clear this back up. And we'll keep going. So my 4.1 moles, I multiply that by 6.02 times 10 to the 23rd, and the total number of moles that I get is, or sorry, not the total number of moles, the total number of formula units or atoms that I get is 2.47 times 10 to the 24th. So I took my number of moles. Each mole has this 6.02 times 10 to the 23rd, and so I take 4.1 times 6.010 to the 23rd FUs, and my answer is then 2.47 times 10 to the 24th FUs, or atoms. Either one would be an acceptable answer. All right, moving on, we have how many moles are in 7.32 times 10 to the 25th atoms of copper. So here, this is like we are on FU Island with our atoms. We're not on Atom Island, we're on FU Island, and we can tell that because it's just copper, not like copper sulfate, not copper hydroxide, just copper. So we're talking about like metallic copper, and it's just a bunch of pure coppers, and they are atoms, not compounds. So if we don't have compounds, we don't need to go to Atom Island. FU Island is our Atom Island. So we are in FU Island, and we need to go back to Mole Island. And if we go up here, what I did was I took my moles and I multiplied it by 6.02 times 10 to the 23rd divided by 1 mole. Here, I'm going in the opposite direction. So if we're multiplying this 6.02, 10 to the 23rd, by our moles, we should be dividing that same number, 6.010 times 10 to the 23rd. We should divide that number by our number of atoms to get back to Mole Island from FU Island. So that means that we take our 7.32 times 10 to the 25th atoms, or FUs, whichever one you prefer to use, and we are going to do 1 over 6.02 times 10 to the 23rd. This will be 1 mole divided by 6.02 times 10 to the 23rd FUs. And when I do this division or multiplication and then division, because we could do this whole number, 7.32 times 10 to the 25th, we can multiply that by 1 mole, or just 1 in your calculator, and then divide that by 6.02 times 10 to the 23rd. But that's just the same thing as dividing 7.32 times 10 to the 25th, dividing that by 6.02 times 10 to the 23rd. What I'm saying is that multiplying this number by 1 and then dividing by 6.02 10 to the 23rd, that's going to be the same thing as doing this operation here of just division. Either one will work, but since we like to do a very methodical step-by-step procedure, we will keep it with our original way of doing things. So I'm taking 7.32 times 10 to the 25th formula units times 1 mole divided by 6.02 times 10 to the 23rd formula units, and I get that there are a total of 121.59 moles. Now, if you run into a situation where you're taking your summative and you notice that your answer is not this, but something like 1.2159 times 10 to the 40th, that's a problem, right? It shouldn't be times 10 to the 40th or 38 or whatever, like a big number up here, bigger than 25, bigger than 23. If you get a number that's really big, you have an issue where you have taken your number, you put your 7.32 times 10 to the 25th in the calculator. So 7.32 times 10 to the 25th, that's in your calculator. And you've done your division, your slash thing. And then you typed in 6.02 times 10 to the 23rd without parentheses. And so your calculator is going to interpret this input as, okay, I want to take 7.32 times 10 to the 25th. That's my first number. I'm going to divide that by 6.02, and then I will multiply everything by 10 to the 23rd. Because this thing here, this 10 times 10 to the 23rd, it does things in order from left to right. So it's doing everything inside the parentheses first. So 7.32 times 10 to the 25th. It'll do all that math to get it into its memory. And then it will go, next thing I see here is division. So I have to divide this number by 6.02, and then I'm done. And whatever I get out of that, I will then multiply it by 10 to the 23rd. And so you get this huge number that doesn't make any sense and it's not correct. So if you get like a big number, you're sitting there taking your summative and you get this huge number that's bigger than 25, bigger than 23, and it's like 10 to the 40th, somewhere, 10 to the 40th, 10 to the 38th, 10 to the 45th, somewhere around there, then you have a problem and you should just raise your hand, let me know, and I'll come over and explain to you what you should do to fix it. So that is a question that you will be able to ask me on the summative. So be aware, big numbers, when you're converting from number of atoms to moles, it doesn't happen, right? So just be careful. All right, let's keep moving. Now we have molecules. So 8.34 times 10 to the 24th molecules of water. We have this many molecules of water, and water, of course, is that H2O. And so it is made of 2 hydrogens and an oxygen. So if we are going from mole island to FU island, our atoms, or we're not going to get atoms. We're going to get the number of molecules out of this. Or we're going to get the number of moles of those molecules. Here, we're starting off on FU island because we're given molecules from the problem. We want to go to mole island. So I take my 8.34 times 10 to the 24th molecules, and I will then use my boat thing. So here's my boat. On top, I will put where I want to go, that is to Mole Island. I put all my Mole Island gear on top, all my Mole Island clothes and my Mole Island activities. They'll go on the top deck where I can get to them. And down below in storage is where we'll put our molecule stuff, which is 6.02 times 10 to the 23rd, and molecule, or FUs. FUs work as well. So those cancel, the bottom here and the top up here, those two cancel, and we are left with just the units that we want, or moles. When I plug this into my calculator, again, remember to put all your scientific numbers in parentheses. So I do parentheses 8.34 E, I forgot my 4 here, so E24. Then I would divide, and I would open another parenthesis, 6.02 E23. The answer I would get from this should be, let's see here, should be 13.85 moles of water. So let's say we decided, instead of going to Mole Island, we divide the screen here. Let's say instead of going to Mole Island, we wanted to go from FU Island with our molecules. over to Atom Island. So if I wanted to know how many atoms of oxygen there were, what I would do is I'd take my number of molecules. So how many atoms of oxygen are in this many 8.34 times 10 to the 24th molecules of water? How many oxygens in that many molecules? I know that there is one oxygen in water, in each molecule of water, so I could take 1 times 8.34 times 10 to the 24th, and that would give me my number of oxygens, which just happens to be 8.34 times 10 to the 24th. And then if I wanted to know how many hydrogens there were, well, I would take my number of hydrogens in each molecule, which is 2, and I would multiply that by the total number of molecules, which is 8.34 times 10 to the 24th. 18.68. So, sorry, doing this math in my head, I didn't have this worked out ahead of time. But that is 1.768 times 10 to the 25th atoms of H. So that's how many hydrogen atoms would be in this many moles of a water molecule. This is like saying, okay, I have 2 red balls and 1 blue ball in a cup. And I also have 10 cups. So 2 red balls, 1 blue ball in 10 cups. In each of those cups, I will have 1 blue ball. And so I will have a total of 10 of those balls. Also, in each one of those cups, I will have 2 red balls. If I want to know how many red balls I have, I would take 2 times the number of cups, which is 10, and that would give me 20 red balls. That's kind of what we're doing here. We're saying there is 1 of these blue balls in 8.34 times 10 to the 24th cups, which means that we have 8.34 times 10 to the 24th blue balls. The red ones, there are 2 of them. And so we have 2 of them in each of these 8.34 times 10 to the 24th cups. And so my total number of blue balls is my total number of red balls is 2 times 8.34 10 to the 24th. And that ends up being 1.768 times 10 to the 25th red balls. Now I can move on to the next one, which says, how many molecules are there in 1.82 moles of copper 2 sulfide? So my number of molecules, we just use Avogadro's number. We are starting off here on Mole Island, and we need to go to FU Island. And so I write out my number of moles, 1.82. I set up my boat. I store my mole stuff below deck where I don't need it. And then I put my my FU Island stuff up top, which is what we're going to need because that's the island we're going to be on soon. That is 6.02 times 10 to the 23rd. That's what goes on top. And these are going to be FUs or molecules. When I do this multiplication in my calculator, it's going to be 1.82 times 6.02 times 10 to the 23rd and divided by 1 mole. So it's basically just a multiplication of 1.82 times this Avogadro's number thing. When I do that, I get a total of 1.10 times 10 to the 24th FUs, or molecule. Again, if I wanted to go now, after stopping over here in FU Island, if I wanted to go to Total Atom Island, and I wanted to know how many atoms of, say, copper there are in this number of moles of copper 2 sulfide, or if I wanted to know how many sulfur or how many oxygen atoms there are. First thing I would need to do is I would need to take this way of expressing my molecule and get a formula for it. So first I know that copper is Cu, and I know that it has a +2 charge on it because of that 2 Roman numerals. And then I look at this next thing and I say sulfide. And I remember from polyatomic stuff that there is a bunch of stuff that has like sulfa something. We have SO4 -2, we have SO3 -2. We also have just S. And we have to decide which one of these 3 things it's going to be. And the answer is, if it's a polyatomic, this will be a T. This will be a sulfate, F-A-T-E, or a sulfite, F-I-T-E. The fight and fate. But this one, just sulfur, since it's just the element, it is "-ide". Remember way back from last semester, we talked about how we could have oxide, which was oxygen. We could have iodide, I-O-D-I-D-E, which is iodine. We could have fluoride, which is fluorine. We have all these other ides, but they're always just a single atom, and they're always a nonmetal too. So here we have this sulfide, and that should tell us that it's not going to be a polyatomic ion because it has that D in the name. It's going to be just the S, sulfur. So my S goes here, and I need to know what is the charge on sulfur. So if I go to my periodic table and I look at it, so I can pull one up. If I look at my periodic table, sorry for all the jumping around stuff, I see sulfur is right here below oxygen. And maybe you remember oxygen has a -2 charge. It does. Maybe you remember that fluorine has a -1 charge, and the things next to it have a -2 charge because they are 2 electrons away from a noble gas. Kind of a middle school thing. Remember, you'd have a -2 charge here on all of these things in this column, because if they gain 2 electrons, they will become a noble gas, like a noble gas, and they will be very stable. But because of that, they have these -2 charges, and sulfur will be a -2 charge as well. Sulfur is also going to be going to have a 2 charge on it, which means that if we do our crisscross, let's see, purple, it means I would take this 2, and I would bring it down here, and I would take my other 2, and I would bring it down here. Now I would be tempted to write something like this molecule, copper 2 sulfide, is Cu2S2, but that would be wrong, because this says that for every copper there is 1 sulfur. For every 2 coppers there are 2 sulfurs, so for every 1 copper there is 1 sulfur. And we shouldn't write these 2's, we should just write Cus. In a similar note, if it were some X element and some Y element, like cobalt and iodine or something like that, and this one was like 3, or let's say we ended up doing our crisscross, we got something like 6 and 4. That would not be correct. We need to get the simplest terms, and since these are both divisible by 2, we will call it 3, which is 6 divided by 2, and 2 is 2 divided by 2. Similar thing happens here when we have Cu2S2. These both have a common denominator, or a common factor of 2, or a common multiple of 2, however you want to call it. And so if we divide both of these by 2, then we just get Cu1S1, or Cus. So Cus would be the correct way of writing this compound. Now I know that there is 1 copper in every molecule of copper 2 sulfide. So just like we were saying with balls and cups, I have a green ball and a red ball in my cup, and let's say there are in each cup, and there were 5 cups, and I would wonder how many total green balls there were, where it would be 5 times 1, and it's 5 green balls. If I wanted to know how many red balls there were, it would be 5 times 1 is 5 red balls. So similarly, we have a total of 1.10 times 10 to the 24th cups, right? These molecules are our cups, and each molecule has a green and a red ball. To calculate the total number of copper atoms, I would take my number of copper atoms in each cup and multiply it by the number of cups. And not do that. What I get then is 1.10 times 10 to the 24th of these coppers or green balls in my 1.10 times 10 to the 24th cups. So it's this many atoms. And I would do the same thing for my red balls. It would be one red ball in each cup. There are 1.10 times 10 to the 24th cups. And so I will have a total of 1.10 times 10 to the 24th blue ball, or red balls. So here in this top half, we went from the number of moles to the number of molecules. Then in this bottom half down here, we went from the number of the number of molecules to the number of copper atoms in each molecule. So this is like saying we went to our molecules, and each molecule is a cup that holds one copper or one green ball and one sulfur or one red ball. And then we said if there's one red ball in each cup, then there's this many total red balls and this many total green balls. All right, so last one. This is 5.56 times 10 to the 19th molecules of this C3H6OH. There's looks like, oh, shoot. I hit the wrong button there. Sorry about that. All right, so there are, this is C3H6OH, and there's like a formatting issue here. This should be something more like CH6OH. We may have seen compounds like this, but I don't think we've really dealt with them. But still, it's good to see this. In this, the only thing that's going to be different about this notation where it has an OH here instead of like C3H7O is that you're going to still have to account all the H's, and there will be 7 H's, 1 oxygen, and 3 carbons. If we were to go to total atom island, you'd have to take that into account. But we'll show you how to do that. So I got 5.56 times 10 to the 19th molecules of this C3H6OH stuff. I set up my boat. I am on molecule or FU island. So I want to put my FU stuff down below. And what goes with FUs? Well, 6.02 times 10 to the 23rd does. On top, I put 1 mole. And we can maybe replace molecules with FU as well so that it matches. Our FUs cancel. We are left with moles, but that's where we're trying to go, back to Mole Island. And so this is dividing basically 5.56 times 10 to the 19th and dividing that by 6.02 times 10 to the 23rd. All right, so if I do that, the answer I get is 0.0000092 moles. Not very many moles. All right, but let's look back to that 5.56 times 10 to the 19th molecules number. If I wanted to know how many carbons atoms there were in this many molecules, let's say that my carbons are my red balls, my hydrogens will be green balls, and then we will have maybe, I don't know, gray balls for oxygen. So there is 1 oxygen. There are 3 carbons, and there are a total of 6 hydrogens here, plus another one, so 7 hydrogens. This is like saying I have 5.56 times 10 to the 19th cups, and that cup will hold 7 green balls, 3 red balls, and 1 gray ball. And then I need to figure out how many balls do I have if there are 5.56 times 10 to the 19th of these cups. So to start with the gray balls, which is going to be pretty easy, that will be just 1 gray ball in each of the 5.56 times 10 to the 19th cup. And so I will have a total of 5.56 times 10 to the 19th gray balls, or oxygen atoms. I'm running out of room here, and we're going to be done anyway, so I'm just going to complete this by finishing with maybe the hydrogens. We'll see how many green balls there are in our cups. That is 7 green balls in each cup times the total number of cups, 5.56 times 10 to the 19th. And when I plug that into a calculator, I get 3.89 times 10 to the 20th. Those will be hydrogen atoms. Sorry, I had to write that down below. Running out of room there. Okay, so again, this is how we go from FU Island to Mole Island, or from Mole Island to FU Island. And also, there's if you have molecules like water or this C3H6OH or copper 2 sulfide, or somehow they will give it to you as a molecule. If you have molecules, you can also figure out how many number of atoms there are of each element in the molecule. Again, if we have hydrogen is one element, oxygen is the other element, then we can use the number of molecules of water and then multiply that, those are like our cups, and then multiply it by the number of balls in each of those cups. So I hope this helped you out a little bit. Yeah, if there's any issues with the sound or timing or anything, let me know, please. And good luck on the summative.